Good morning, students. Today, let us discuss about the expressions. Basically, the expression is a collection of operators and operands. So, a simple example is nothing but like when we take a operator, say A plus B. This is one expression. If I try to do another one, let us say multiplied with the A into C. So this entire we will call it as a expression. So in this there are two basic symbols or exist. One is the operator. So here the operator is addition, multiplication, and the other multiplication. And the operands are nothing but the variables. So here the operators are nothing but operands are nothing but A, B, and C. These three are operands. So the value on which the operator performs the task, that is nothing but the operand. Operators are nothing but some symbols which does the arithmetic or logical operations or otherwise conditional operations. So any expression generally contains two things. One is the operand, the other is the operator. Okay. So basically expressions can be classified into three groups, either infix notations, postfix, or prefix expression. So now this notation is nothing but the infix notation. So as such, whatever you have in a mathematically, that is nothing but the infix expression. The postfix expression and the prefix expressions are also there. The postfix expression, the operand will come first, then followed by the operator. So which means that any infix expressions can be converted into a postfix or prefix expressions in order to increase the speed of the compilation. So which means that in general in a data structures we will come across with this, but as of in the programming level we will generally give a input in the form of infix expressions only. So we will not to worry about the postfix expressions or prefix expressions, but we need to know that there are three kind of expressions: infix, postfix, as well as the prefix expressions. Okay, so the prefix postfix expression is nothing but first the operand will come and then followed by the operator. When you go on the next one, which is the prefix, the operator will come first followed by the operand. So in general, where we are using this prefix or the postfix means this notation is always faster than the infix, because it need not to worry about the bracket which one want to have a highest priority, so that I can go for executing that first. So that check conditions will not be mandatory in the prefix or the postfix. So that's why in general when we are moving on to a compiler level, we will have a postfix expression or a prefix expression notations. So as of now in C programming, we will generally use the infix notations only. So the expressions in general, what we do is the first priority will be given for the brackets. So whichever is given inside the bracket, first that could be executed, and then followed by the order. So which means the x power 2. So that kind of expressions will be executed after the bracket. Then followed by the division, followed by multiplication, then addition and subtraction. So this order, that is BODMAS, will give a order in which we need to execute. Okay. So this order we will generally use it in a mathematics. The same is also applied in any languages. Okay. This is for our information. Fine. So now we will move on to the precedence order. like we have so many arithmetic operations, logical operations, assignment operations that we will discuss now. Before that, whenever we have the elements inside the brackets, those always has the highest precedence, so that will be executed first. Okay, and in general, the second one is nothing but all the unary operators. So the unary operators will have the second priority, and then followed by the arithmetic operators, in which multiplication, division, and modulus will have the next precedence, and then the addition and subtraction will be followed on. Then the fifth priority will be taken given for the shift operators, that is left and right shift operators. And then sixth one is nothing but the less than or equal to, greater than, or greater than or equal to, that is the relational operators. And also we have a relational operator equal to and not equal to, that comes after the precedence of the less than and greater than. Okay, and then followed by the bitwise operators. So this is the order in which the operators can have their priority, or we can say the order in which the particular expression should be executed. And also there is a associativity, which is nothing but like the brackets always it try to perform from the left to right, and then the unary operators always does from right to left. Just keep this in your mind, so that the rest all are left to right. Okay, so what are the right to left associative contains means like the unary operators, and then not, negation, pointer, address, and size of. So these all are right to left. Okay. So first it takes the left hand side element and then it performs the right. Other than that, all the expressions will be performed in the order of left to right. Okay. So this precedence gives the the priority or the preference. Okay. But when we go for the associative, it tells whether you want to execute from the left to right or a right to left. The movement of the expression you need to perform and then hold that resultant and give it for the next expression. Okay, so that we'll discuss one by one. Then we'll move on to the operators. So what does my operator means? It's nothing but just a manipulation for the constants and variables. So operators are nothing but symbols, as we already aware about. So the operators are special characters that instructs the compiler to perform mathematical or logical operations. So this is the basic concept of operators. Okay. So the operators are classified into a 10 categories: the arithmetic operators, relational operators, logical operators, increment and decrement operator, comma operator, arrow, assignment operators, bitwise operator, size of operator, conditional, or we can also call it as a ternary operator. So we have basically 10 different groups under which all the symbols, that is the operators, are going to be classified. Okay, so first let us discuss about the arithmetic operators. So I have given a simple example. So in this, what are the arithmetic operators means? Addition, subtraction, multiplication, division, and this is nothing but modulus. What is the modulus? It is trying to provide you a reminder. Okay, we can also call it as a mod operator. Modulus. Sorry. So this is nothing but the addition. So what I am going to do is I'm going to consider two variable as an integer data type. A is 20 and B is 10. So we can try to perform the addition minus multiplication, that is star operator you must use, and then for the division you can use a slash, and for knowing the remainder we can use the modulus. So this is nothing but the remainder. So this modulus operator will always try to return the remainder. Okay. This is the output. If you execute in a system, we will get 30. So when you add 20 and the 10, you will get 30 as an output. And when you are subtracting, obviously you will get 10. When you do multiplication, you will get 300. And when you are doing a division, if this is an integer data type, means the return type is also a integer. So there will not be a quotient. Okay, it will say, for an example, if your a value is 30, say 37. So 37 divided by 10 means it will not return 3.7, it will return only 3. Okay, because the data type is also B. So it will try to provide only a integer. It will not give a float data type. Okay, suppose if you want to get the float, then you need to change this into a percentage f. Okay, so now we will consider as a integer. So I will get output as 2. Okay. And what about the modulus? That is the remainder. 20 mod 10 is 0 only, right? It is divisible, so that the remainder is going to be 0. Say for an example, now a is 22 means 22 mod 10. What is our remainder? 2. So in that way, the output will be getting. So now we will move on to the relational operators. So the relational operators are nothing but the comparators. So the comparator, when you are trying to compare two variables, either it may be a less than or greater than, or you can say greater than or equal to, less than or equal to, or otherwise simply equal to or not equal to. Okay. So this exclamation mark says that it is nothing but a not symbol. Say now a value is 10 and b is 20 when we compare the a and b. So a is greater than b. So always the relational operator will try to return the true or false. So which means that either 0 or 1. So true means 1. If it is a true means 1. False means 0. So what happened now? A 10 will be compared with 20. A is greater than B? No. So it will try to return 0. And when you compare A and B, A is less than B. Yes, now this is true. So it will try to return 1. And when you're comparing A is greater than or equal to B, no, it's not greater than. So it will try to return 0. And also it checks for the equal to. So say for an example, suppose B is also 10 means at that time you will get this value as 1. Okay. So now assume the previous one itself. Then let us say now A is less than or equal to B. So less than or equal to B, Yes, of course it is less than, so it will try to return 1. And then when we go for the a equal to b means it's not equal to, so it will try to return 0. And then the other one is the a is not equal to, so not equal to, obviously it is not equal, so we get a resultant as 1. Okay. The next operator is the logical operator. So in the logical operator there are three things. One, basically it may be classified as and, a, n, d, and operator, double ampersand, and then this one is the or operator, or, double pipe symbol, and then the other one is the not operator. Okay. So if you consider the logical operator, you can simply combine the any two relational operators. Okay, so that is the basic objective where the logical operators are going to use. So it can try to combine any relational operators in order to get our outcomes. So say the truth table for and. Say now I will consider a and b value as an input. Say the first expression will try to provide me a 0, and then the second expression also provides me a 0. At that time the and, what it does is, if both are 0 means we will get a output as 0. So this logical operators are also going to return true or false. Okay, so what happened now, assume the first expression is going to give 0 and the second expression is going to provide true. So this is false and this is true. So if that is the case also, the and will be always when both the output is said to be 1. Then only I will get the output as 1, which means the true. If both the inputs are true, I will get the output is also true. But in the OR operator, it's like any one of your expression returns true, then I will get the output as true. Okay. And when we are moving on to a NOT operator, so a NOT operator will have only one operand, say NOT of A. So whenever you have a value as 0, the output of NOT A is 1. If it is 1, you will get the 0. So this is the basic truth table for and, or, and not. Hope you can understood. So now we will go for the programming. So assume A is 10, B is 20, and C is 30. So what happened now, when you are doing a comparison, there is the relational operators. So what I'm doing is I'm trying to compare A and B first. So what happened, A and B will be compared. Is that A is greater? No. So what happened, this will try to return 0. And what about the C is greater than B? C is 30. 30 is greater than 20. Yes, this will return me 1. So now 0 and 1. What is 0 and 1? 0 and 1 is nothing but and. So now we are doing the AND operation. So it will try to return me 0. So you can see the output is also 0. And in the second expression, I'm trying to go for the OR. So the same expression, you are going to have 0 and 1 here. The expression that is A value, A is greater than B. No, it's not A is greater than B, so it is 0. And similarly, C is greater than B, it is 1. So 0 and 1. Now you can see the R is returning 1. Okay? So I will get the 1 as an output. And similarly, for the NOT. So the output of this, so the exact output of this, I'm going to just negate it. So which means I'm just going for the not operator. So it's just a reverse of your output. So whenever you get 1, obviously you'll get 0. So you can see here you are getting a 0 as an output. So this is how the logical operators are going to function. So logical operators, when you are trying to compare any two objects, that is expressions, for that you can go for a logical check. Relational is comparing two elements. Logical operators compares two that is relational operators or any expressions. Okay. Next we'll move on to the increment and decrement operator. So the unary operators, basically it contains two things, increment or decrement. So there are two incrementation and decrementation operator, and this operator will also have pre or post. So in the C language, say if I'm going to take any variable, let us say a increment a plus plus, this is nothing but the post. So I'm getting the operator after the operand. And the other one is plus plus a. This is nothing but the pre. So plus plus a, which is nothing but the pre-incrementation, a plus plus is nothing but the post incrementation. Similarly, you can also have minus minus a, that is nothing but a decrementation, that is pre-decrementation. Similarly, a minus minus, this is nothing but post decrementation. So the operator follows the operand, means then we can say it is a pre. The vice versa is nothing but the post. So the difference are there in order to perform your operations. Say we have a pre-incrementation operator, post-incrementation operator, pre-decrement as well as the post-decrement. So here some of the examples are given. So basically the syntax is nothing but plus plus the variable, minus minus the variable, and similarly variable followed by the post. So here the examples are given. So these all are pre-incrementation operations, and this all are post incrementation operation. Okay. So what happened? The operator come first followed by the variable, okay, in the pre. In the post order, the variable come first and then the operand, that sorry, operator will come next. So the post. Okay. So these are some of the examples. Mostly in incrementation, in our looping and all, we will be using plus plus I plus plus, minus minus I minus minus. So what happened here is the value of I is incremented before assigning to the variable. Just keep in your mind whenever you are going for the pre-incrementation, means first the value will be incremented and then only it will be assigned. Okay. So before the assignment, the value will be incremented. In the post incrementation, the value of I is incremented after assignment. Okay. So the after assignment, in general, the value will be first given and then only it will be incremented. Say for an example, if I am giving a value as 10. Okay. When I give a plus plus, I will try to declare one more variable, say b, and this maybe I will declare it as an integer. So integer a equal to b, sorry, a equal to 10, and then b equal to, I will just declare a variable b. So now what I'm going to do is plus, I will just assign b equal to plus plus a. So if I gave like this, what happened? First, it increments the a, and then it will be assigned. So what happened? Now I will get my output as 11. So b value is nothing but 11. What about the a? A will be 11. And suppose if I gave, I will also declare one more variable c. So what happened? If I gave c equal to a plus plus, if I give a plus plus, the output of c is nothing but just a 10 and all. Okay, so that is the difference. Why? Because of here, just assume that this is a different statement and this is another statement. It's not going to be a continuous one. So a value will be first saved in C, and then only a value will be holded, incremented. So what happened in a variable, when you are executing the third statement, the C equal to a plus plus, the a value will be 11, but the C value is going to be the same 10. Why? Because of first it assigns the value, and then only the incrementation process will be carried out. Okay, so that is the basic difference between the pre and post. So in the pre-incrementation, the value will be incremented first and then assigned. In the post, it first assigns the value and later on it will try to increment. So we can say the incrementation will be done last. Okay, and similarly on the decrementation process. So here what happened, if you assume a value is as a 10, pre decrementation means it will give a 9 as an output. For the post decrementation, the 10 itself you will get it as an output. Okay, so in the I means, if you are trying to hold in the same variable means, you will get the decrementation after performance. Okay. So when you are holding it in another variable, you can see the reflection. You can see in this example, like one of the program is given here. Say I is meant as 1 initially, and we are using a while loop so that continue repeatedly we are going to perform this. So what happened, first I value will be 1, so it will try to check 1 with 5 because it is a post incrementation. So we will get output as 1 first when you are trying to print the statement. So what happened, after performing this loop, late then only the I value will be incremented. So now the I value becomes 2. So when it is comparing 2 is less than 5, yes, it is true. So it will go and print the I value. So now I value will be 2. And again it will repeat. So now I will be incremented by 3. So 3 is less than 5. Yes. So it will try to print the I, which is nothing but 3. And again it will be in a loop itself. Now I becomes 4. 4 will be less than 5. Yes, of course, it is 4 is less than 5. So it will try to print the I value. Now what happened? Now I will be incremented as 1. So now I will get the I value as 5. So when it equals, so because it is checking for the less than symbol. Now it is equal, so that the while loop gets terminated. So which means that it will come out of it, the loop. So that's why we will get only output 1, 2, 3, 4. Okay. Hope you have understood. So in order to understand the same, it is given in a statement. So when it reaches 5, we will try to stop the output. And here one more example is given for pre-incrementation. So you can see here I, that is plus plus I. So what happened? When it takes the I, first it increments the I value. So that's why now it is not 1, it is 2 now. So already I value is 1, so 1 plus plus. So which means that I equal to I plus 1. So 2 is there. So 2 is less than 5. Then 2 will be printed. So we will get 2 as an output. But in the previous case, 1 also we got. Okay. And then it will increment furthermore. So now I becomes 3. I is less than 5. Yes, it is less than. It will try to print the 3 and then it increments. And now I become 4. It will print the I value. Then I become 5. So once it reach 5, now we need to, the while loop gets terminated because it is equal. So the loop statements always see to that if it is true. Once it is true, it will execute the inner statements. If it is not true, it will come out of the loop. So this is called as a scope. Scope for that loop. Okay. Hope you have understood what is the difference between the pre and post. So in a pre, first it will increment and then use data. In the post, first it takes the value and then it will try to check. And later on, like last, after performing this statement, last only it will be increment. Okay, just keep that in your mind. Probably whenever you are going for your 1 mark questions, you may expect this kind of outcomes. And the explanation is given. And this is another example for post decrement. So as of now, we have discussed about the incrementation operations. Now we will discuss about the decrementation. So what happened initially? The I is 10. So 10 is 10. This is the post. So first 10 will be taken as such. 10 is less than 5. Yes, it is less than. Hmm? This should not be a less than. It should be a greater than. Okay. So if I is greater than 5, yes, of course 10 will be there. So it will try to print the 10. Okay. And then 9, now I will be reduced by 1. Yes, of course now it is 9. So 9 will be printed and then I will be decremented by 1. 8. So 8 is greater than 5. Yes. So that it will try to print the 8 also. And then again it will be decremented by 7. When it reaches 5, I5, then it's going to be equal. So at that time I is not greater than 5, isn't it? So during that, after 6 we will get a 5. So at that time it will try to terminate from this while loop. So we will get 10, 9, 8, 7, 6. What happen if we are changing this into a pre-decrementation, which means I minus minus. So if you change that, you will not get the 10 first. Okay, you will get 9, 8, 7, 6. Is that clear? So you can see this is the output for pre-decrementation. So you will get 9, 8, 7, 6 as a output. Okay. So now we will move on to the next one, which is nothing but the comma operator. So the comma operator will be used in order to separate. So a multiple declaration of variables, we can use a comma operator. Okay, and also when you have a lowest precedence, which means having lowest priority, so that will be evaluated at the last. At that time also we can use the comma operator. The other one is returns the value of the rightmost operand when multiple comma operators are used inside an expressions. So inside the expression, if you are using multiple comma, which means that on it will try to take it from the rightmost and then assigns. Okay, and then like the variable values you can also provide, and then acts as a operator in the expressions. Say we have one example so that you can understand better. So in this comma operator, you can see I'm just declaring the I value and j value, I and j as an integer data type, and we are just giving this statement, that is I equal to j equal to 10 comma j plus 20. So which means that the multiple expressions are given here. So what happened? First it will try to assign 10 to j comma, which means that after completing this statement it will move on to the next. So now j plus 20. So what happened? Now j value is 10 because it assigns 10 to j. Okay, and then now j plus 20, which means 10 plus 20. What is 10 plus 20? It is nothing but 30. The operation will be performed, and then where it will store? It will try to store in the I. So now the 30 will be stored in the I variable. Okay. So when you try to print the I and j is nothing but 10, because we are not changing the j. J still it is nothing but just a 10 only. And this j plus 20 will be assigned inside the I variable. So I will be 30. So when you execute this, you will get an output as I equal to 30, j equal to 10. Okay. So the comma operator is nothing but you can try to give multiple expressions in a single line statement. And the next one is the arrow operator. So the arrow operator basically used in the structure members, like a pointer. When we are trying to use the pointer variable, this arrow operator will be used. So probably when we are discussing about the structures, we will make use of this arrow operator. So just keep in your mind, like whenever pointers are used in order to access the structure, the arrow operator is going to be used. Okay. The next operator is nothing but the assignment operators. So the assignment operator, it's nothing but just some value is going to be assigned in a variable, or some expression is going to be assigned in a variable. So here you can see the example, num equal to 25, so that the number value is nothing but 25, age is 18, y value is 3.14, and some expressions also you can provide. So area equal to 3.14 into r square. So these all are nothing but simple assignment operator. So we are using a equal to, that is nothing but a assignment operator. Okay. And also there is a possibility for shorthand assignment operator. So in general we are giving a equal to a plus 1. This is one expression, right? So instead what you can give is a plus equal to 1. So this also same as the a plus 1. Okay, which means that say if a value is 5. So a equal to a plus 1. What is the output of a? This is nothing but 5 plus 1, right? So which means that it is nothing but a 6. The same thing, this also is nothing but a, you will get a same output for this statement. So only thing is you can just shorten the operator by clubbing this. So the plus arithmetic operator followed by the assignment. Similarly, subtraction operator followed by the assignment. It's nothing but just a equal to a minus 1. When you are expanding this, so your compiler can able to understand that the shortened operator is nothing but the expansion of either a followed by the arithmetic operation followed by the assignment. So this is something similar to the same expression. Okay, and here what we have given, a star equal to 2, which means that a equal to a into 2, and this is nothing but a equal to a divided by b. Okay, and this is nothing but a equal to a mod b. So this all are called as a shorthand. So either you can provide this way, or otherwise you can also use the shorthand operator. Okay. So here you can look on the program. Like initially we have declared a, and a value is assigned as 11 when we give a plus equal to 4. This is something similar to a equal to a plus 4. So now what happened? 11 plus 4, which is nothing but 15. So you will get output as 15. Okay. So here what we are doing, we are just subtracting it. That is nothing but a equal to a minus 4. So what is a? A is 11. So 11 minus 4. Yes. So you will get 7. And similarly multiplication. Okay. And the division. Modulus. So you will get your output 15, 7, 44, 2 and 3. Just try this in your machine. And then other operator is nothing but the bitwise operator. So whenever you are working with the bits in the binary representation, there comes this bitwise operators. So the logical operators, the mathematical operations, all are logical operators, arithmetic, that and all comes under the logical unit. So when we are speaking about the binary, then the bitwise operators might be useful. So to perform the bit level operations, so this is the key point you need to keep in your mind. Like whenever we are going to work on the bits, then this bit level operators are going to be utilized. Okay, so in a bitwise operator we have a and, or, not, XR, left shift operator and right shift. Okay, so this 5, not 5, 6. So these are basic bitwise operators. We'll discuss one by one. Okay. So as I said, bitwise and, bitwise or, one's complement, or we can say not operator. The other one is the shift right. You can see wherever the arrow direction is flowed on. If you are using a single less than symbol, means it's a logical operator. When you want to go for the shifting operation, then you must use a double greater than symbol. Okay, and similarly shift left, so double less than symbol. So what is the basic difference here is the shift operator will shift one position of your binary input. Okay. So we'll discuss with an example, okay? And the cap symbol is used for meant for XR. When we are working with the electronics components, probably these bitwise operators are essential. Okay. So just understand that there is a truth table for this bitwise operator. So whenever you consider any two inputs A and B, okay, if both are 0 means, say this is nothing but the AND, bitwise AND. This is OR. The pipe symbol indicates it's the OR operation. And this is nothing but the NOT. Sorry, this is NOT. This is nothing but XR. Okay. So if you consider your input both are 0, then when you are performing the AND, like AND means whenever both the signals, that is both the inputs are true or 1, then only I will get a output as 1. It's same as the logical operator. Okay. So logical AND as well as the bitwise AND, both are truth table is common, but one thing is there we are going to work on the logical value true or false. Here this is going to be a binary. Okay. And then say OR operation, whenever you have 1 in any one of the inputs, then we will get the 1. Okay. And XR, at least both the inputs should not be same. Okay. So here you can say 0 and 1. So we are getting 1 as an output. Here A is 1, B is 0. So you will get a 1. If both the inputs are same means, if both are same, at that time we will get a 0 as an output. This is the truth table for XOR operation. And NOT is nothing but the same as NOT. So you will have only one operand. So whenever you have a 0, the output is going to be 1. If it is input is 1 means you will get a 0. It's same as your logical operator. But the difference between logical and bitwise is nothing but logical operator will work on the expressions and fetches some outputs based on the relational operator or any expressions, say that is going to give either true or false. Here we are working on the binaries. Okay. Same, there also you can just correlate true is 1, false is 0. That's it. So here we have considered one program. As I said, like this is going to be the binary information. So we will try to declare the variable as unsigned integer, because I will not get the I'm not going to give a negative value. Okay. So that's why I'm just declaring it as a unsigned. So unsigned int a equal to 60. So you just try to convert this integer into a binary. Okay, so this is the binary value for 60. Similarly, b is taken consider as 13 now. So the binary value for 13 is this one. When we are trying to perform the AND operation, okay, so A and B. So what happened now? A and B is there. So just in a AND, whenever you get 1, 1, then only the output is going to be 1. Otherwise, we will not get the output. So here you just compare the first position 0 and 1. So 0 and here the B value is 1. So whenever you have A and B as 1, 1, no, both should be 1, then only I will get the 0, 1. So here 0, 0, so 0, and then 1, 1, 1, 1, so both are 1, so I will get the output as 1. Okay. and here also we are getting 1 1, so we will get 1. Here both the input 1 and 0, it's not both are same, so I will get a 0. It's not same 1, so you need to take this as A and this as B. 1 by 1 binary you need to compare and then see to that whether it is equal or not. Okay, and when you are moving to the OR operator, what it does, the same thing, but if it is 0 0, the output is going to be 0 in OR operation, right? Other than that, you will get 1 as an output. So now 0 1 1 0 0 0 1 1 1, the next is also 1 1, you will get 1, and 1 0 1 1 0, again 1, and then 0 0 0 0 0 0. Okay, so this is how OR operator will be function. And the next one is the XOR. So in the XOR, if both are same, at that time I will get 0. If any one is 1, the other is opposite, then I will get a 1 as an output, right? So in the, you can also compare them. So the XOR operation, when 0 0 1 1, you will get the output as 0 0. Okay, either any one is 1 means you will get the 1. So now here you can see 0 1, so I'm getting 1 as an output. When it is 0 0 0, when it is 1 1 0, 1 1 0, 1 0 1, again the next is 1 1 1, and 0 0 0, the next is also 0 0 0. Okay, this is nothing but the XOR operation. The other one is the NOT. So here you can see only one operand is used. So let us consider only A alone. So in the A alone, that is negation of 61. So wherever you have 0, replace it as 1. So here it is 0, replace it as 1. Again 1 you have, so change it to 0. Then 1 means 0. Again it is 1, so 0. Again 1, 0. Now you are having 0 here. This is also 1. And the next one is 1. Sorry, 0. Now you will get a 1. Just negate this. Okay. So just change this. So now it becomes 1 1 0 0 1 1 0 0. Fine. And the next is nothing but the shift operator. So less than, double less than means left shift. So this is nothing but the left shift operator. So what happened? The left shift operator means it shift one or two times. So here it is mentioned twice. So which means that it will try to shift two positions. So see here, the output of this is nothing but just shifting to two positions. So that's why this one is taken here, and this one is taken here, and this one is positioned here. So just one shift. So that's why 4 ones followed by 4 0. So two shift, left hand side. The other one is the right shift. So what happened now? This will be shifted on the reverse direction. So this one, that is 2 times it is going to shift. So this one goes here, this one goes here, and the third one comes here, like that. Okay, so that's why we'll get 0 0 0, that is 40 followed by 41. Okay, so if you see the output, it will be printed in the form of percentage D, right? Suppose if you are expecting the output in the binary itself, means instead of using a percentage D, you can give percentage U. Okay, so that you can see it in the unsigned binary number. So the corresponding integer values are printed here. I think this we have explained now. The last one is the size operator. So the size operator, in general, it will try to indicate what is the memory allocated for the data types. Okay, so the size of its operand can be easily understood. Okay, so the size of operator always precedes its operand. So to calculate the size for the data types or a variables, we can try to use the size of function. This can be nested also, and then returns the size in the integer format. Okay, so like we'll consider one example so that you can understand. So I'm declaring four different variables in different data types: integer, float, double, and character. And I'm trying to check what is the memory allocated for the data type, for the variable A, B, C, D, and all. So the size of A, size of is a predefined function. Okay, so what I'm going to use is, this is a size of function which will try to tell the buffer allocated for this variable. So integer is the data type, so it will try to provide the 2 as an output. When we provide a float, that is B variable, this will try to return me 4. Double means 8. Character means 1. So you can see the output 2481. So we'll stop up to this. Hope you have understood all the basic operators.